Okay, so for this video, I'll be doing the MCQ and structured question for magnetism and electromagnetism. Okay, this is part 1 of the video because these are things that we have already learned. Okay, more of magnets. Okay, so for MCQ 1, in two separate experiments, magnet is brought near an unmagnetized iron bar. Okay, so what are the poles induced at X and Y? So if this is brought near and this is iron bar, which is a magnetic material, here will become a north, and here will become a south, and Y will become a north. That means X must be north and Y must be north as well. So answer is A. Okay, question 2, magnetic fields around two bar magnets shown. Which diagram represents the correct arrangement of the magnetic poles? Take note that magnetic field lines come out from the north, right? So the field lines, as you can see, comes out from here. So here will be a south, and here will be a north, here will be a south. So I just need to look for this combination, and the answer is D. Okay, question 3, it shows the magnetic field around wire X, which carries a current into the paper. That means you need to use your right hand grip rule for straight wire, okay, with the thumb facing in. Okay, so that's how you can get this clockwise direction. Okay, clockwise direction. And you notice that the circles, the gap between the circles get bigger and bigger as you move away from the wire, which means the field strength is weaker. Okay, if the wires, if the field lines are very close together, which means it is very strong and concentrated. If the field lines are spread out, okay, that means it is very weak in this region. Alright, and the gaps will become bigger. So if I were to draw the next one, it will look something like this, keeping the same direction, and the next one will look somewhere like this. The gaps gets bigger and bigger. Okay, so the arrows on the field lines actually shows the direction on a south pole. Okay, because as you know, field lines go from north to south, and if I have a south pole here, it will actually act on here. Okay, because as you know, the magnetic field lines comes out from the north and enters the south, so it is the direction of the force on a south pole. Okay, question 4 we'll skip for now. I've not covered that yet. Question 5, the ends of 3 metal rods are tested by holding NQ of rod 1 close to each end of rod 2 and 3. Okay, results are as follow. NQ attracts NR, so they attract. Okay, NQ attracts NS, so they attract as well. Right, NQ attracts NT, and it repels U. Okay, so the only test if it's a magnet is if it repels. Okay, so NQ is actually a magnet. Rod 1 is actually a magnet. Okay, and because it's able to repel NU, that means rod 3 is also a magnet. Okay, repulsion is the only test for magnet. Whereas for rod 2 is attracted to NQ, right, from NR. Q and R attract. Q and S also attract. So rod 2, I can just say that it's a magnetic material. So the question is asking which one is a magnet. The answer will be 1 and 3. Okay, so it's C. Okay, you can do question 6 as well. So the magnet is broken into 3 parts. So if here is north, here will be south. Then because it's actually made out of many atomic magnets. Okay, so this one is easy. Answer will be D. Okay, then we are going to the structured question because the rest I haven't really covered. So structured question, state 3 properties of magnets. Okay, this is question 1. State 3 properties of magnets. Any magnets have two poles, the north and south pole. First property. Like poles repel each other and unlike poles attract. Second property. And they attract magnetic materials. Give examples such as iron, nickel, cobalt, and steel. And also, the next property is magnetic force of a magnet is stronger at its poles than in the middle. And lastly, a freely suspended magnet always points in the north-south direction. So any of these three properties will get you the 3 marks. Now, distinguish between temporary and permanent magnet in terms of their properties. So for temporary magnet, they lose their magnetism when removed from the external magnetic field. Permanent magnets remain magnetized, even without the influence of the external magnetic field. So that's how you get your 2 marks. Okay. Now state a material that is used to make a temporary magnet and a magnet that is used to make a permanent. Iron is a temporary magnet because it's a soft magnetic material. Steel is a hard magnetic material. Alright. So we'll go to question 2. Okay, complete the diagram below to show the magnetic field lines of the bar magnet, indicating the direction of the field lines. Okay, so magnetic field lines always comes out from north and enters south. Alright, and the field lines cannot cut each other, and you must draw sufficient field lines to show the pattern. Okay, but make sure that they don't cut each other or touch each other. Now, what feature in our drawing indicates a strong magnetic field? If it's a strong magnetic field, the field lines will be close together. Okay. Yeah, this is why I mentioned correct direction of field lines, no intersection, and they are closer at the poles of the magnet, and they come out from north and enters the south. Okay. So how do we explain this? What feature in the drawing indicates a strong magnetic field? Distance between the lines indicates the strength. The closer the lines, the stronger the field, right? Next, we'll go to question 3. Okay, this is a current carrying a wire carrying a current into the plane of the paper, right? That means your thumb should be facing inwards using your right hand grip rule for straight wire. Okay, they want us to sketch the magnetic field due to the current, and it should suggest the variation in the strength. Okay, show the direction of the field with arrows. Okay, so I will need to draw to show you. Okay, if I were to place my thumb into this screen, okay, I will make a circle with my fingers, and the direction will be clockwise. Okay, please try this. This is important. Now they want us to show the variation of the strength. So the first one is pretty close. Okay, second one will be further away but keeping the same direction, and the last one, the gap between the second and the third must be larger. Okay, and the direction must be clockwise. Okay, then state the feature of the magnetic field patterns that indicates the magnetic field strength. Okay, spacing between the concentric circle is closer where the field is stronger. Okay, so if I want, I can draw another one. Okay, and the gaps are actually smaller between the first and the second and third and fourth. Okay, state the effect on the magnetic field and change to the magnetic field pattern if we decrease the current. A stronger current will produce a stronger magnetic field. So if I decrease the current, the magnetic field strength will decrease and the spacing becomes further apart. Alright. Okay, then we move on to question 5. Okay, 3 pieces of soft iron blocks. So they are soft iron. That means they are temporary magnets. They can be made into temporary magnets. They are soft magnetic materials. They are placed end to end with each other next to a magnet. Okay, when placed near a box of nails, some nails were attracted at the end of the block. Describe the process that brings about the iron blocks attracting each other. Okay, so this is magnetic induction, right? Which is a process whereby the north pole of the magnet will induce a south pole on the side of the block nearest to it. So here will be a south. Since opposite poles attract, the magnet and the block will attract each other. So the block is now an induced magnet because here will become a north, south, north, south, north. So even here, the top part of the pins will be south, the bottom will be north. Okay. So the first iron block will now become an induced magnet. It will in turn induce an opposite pole on the other block. And the process continues, resulting in the blocks attracting one another. So as you can see from here, then indicate on the diagram above the magnetic poles, if any, on each iron block. We have done this. Discuss what will happen to the iron nails if the magnet is removed from the first block. Okay, as the iron is a soft magnetic material. Okay, it's a soft magnetic material. It will not retain its magnetism. The blocks will then lose their magnetism and it can no longer attract one another and the iron nails. Therefore, blocks and iron nails will drop. Okay, so this is question 5. Let's go to question 6. Okay, question 6, it shows 4 circles representing plotting compasses in ABCD. Draw an arrow inside each circle to show which way the compass needle will point. So again, this is asking about the direction of magnetic field. And we know that it comes out from the north, and the compass will always point in the direction of the magnetic field. So if I were to sketch, I would draw a magnetic field line coming out from north and entering south. Then there will be one loop over here. Okay, take note that the magnetic field lines do not touch. Okay, so it will come out. So I may also draw one more here. So the field lines, the compass needle will point in the direction of the field lines. That's why B will point in this direction. For D, it will sort of point like that. C, it will point maybe inwards. Alright. And after that, they want us to draw the magnetic field between the two magnets. And C, draw the magnetic field lines in the region. Okay, so just check your answer for A, B, C, D. Right, so it's something like that. Okay, basically the field lines must go into south. Okay, and come up from north. And compass always point in the direction of magnetic field lines. Okay, then they want us to draw the magnetic field between the two magnets, so I don't need to care about the rest over here. I just need to draw. And there is also a neutral point here, right? Because the field lines cannot cut each other. The field lines should not cross or intersect with one another. Okay, and they should come out from north, right, for both magnets. Then there's this null region, which is marked out by this X, where the field lines cancel one another. So there is a region void of magnetic field lines. That means there is no magnetic field lines. Okay, for part C, because this is going to be an induced magnetism, so here will actually be a south, right? Because it's just a normal soft iron bar. Okay, so the magnetic field lines will come out from north and enters the south. And again, take note, there is symmetry of lines. Okay, that means you try to make it as symmetrical as possible. Then correct direction of field lines from coming out from north and enter south, and there's no intersection of the field lines. Alright, so this is question 6. Okay, after I finish teaching the other part, then we'll do the other questions.